This shows you the continuum. You'll see this over and over in exercise physiology books. When we look at the phosphagen anaerobic systems on the far left and the aerobic system on the far right, we see the contribution of the energy system based upon intensity and duration. So you'll see that a boxing match is 50% anaerobic, 50% aerobic. And if you think about it, there are jabs, punches, quick bursts, but yet you have to have the ability to maintain that activity and kind of dodge and weave. If you're going to do a 2-mile run, you're still having the anaerobic system contributing. However, it's primarily aerobic that's doing the job. So in terms of intensity and duration, we have this relationship of contributing energy systems. This also is looking at the systems with intensity and percent ATP supplied by the different areas. So we have very high, moderate, and low intensity exercise. You look at the ATP contribution of the three systems. You'll see that the phosphagen system is the burgundy, and once you get, that's the primary energy source for ATP production. We see the blue as the aerobic system and how it slowly rises and it becomes the big representer of ATP production for lower duration intensity, lower intensity, and for moderate to high, we have kind of an equal contribution from all three. So the anaerobic energy system starts with carbohydrates, and you see the glucose at the top. The glucose at the top, you'll see that there are 2 ATP that are required to start to metabolize that carbohydrate to get it in the right form so it can move forward. It gets split into 2 halves, and you have the production of 4 ATP. So you have the cost of 2, production is 4, 4 minus 2 is 2. So it's not a big producer for ATP, but it's quick and it can contribute for rapid, higher intensity activity. The aerobic system involves fats, carbohydrates, and proteins, and you'll see the fats being broken down by beta oxidation, carbohydrates going through glycolysis, and proteins being deaminated. Proteins are able to fit in, you don't confuse, it doesn't fit into glycolysis. Pyruvate is the end product of glycolysis just before it gets into the citric acid cycle. So you have the contribution of all 3 systems potentially available. Pyruvate, which is the end result of glycolysis, if you are in a high intensity activity and pyruvate is the aerobic system is not able to turn on effectively, you're at a high intensity and you're not able to get enough oxygen in via the lungs, it's going to convert to lactate, and that shuttles away, but that allows glycolysis to continue. So you remove the product and allow the energy cycle to continue. The final process of getting glycolysis into the citric acid cycle is the formation of acetyl-CoA, and that requires oxygen. The citric acid cycle has a number of steps, and this is the representation. It appears always as a circle, but it's not truly a circle. It's just easier to view it as a circle. You'll see that there are some intermediate energy carriers noted as NADH, FADH2. and GDP. Those are ultimately going to be part of the ATP production process. And the citric acid cycle is occurring inside the mitochondria. I should have mentioned the glycolysis is in the cell cytoplasm. Carbohydrates are really important for an energy source. When you have low carbohydrate intake, muscle protein can be broken down, and that is where we have this deamination and ability for protein to be able to fit in as needed. So with especially longer duration activity, high intensity activity, we really need to have carbohydrates. So when you look at your nutrition coach question, which was at the beginning, we take a look at this and see, okay, now can I answer those questions that were asked? So this is an 800-meter track athlete who wants to eat a high-fat, high-protein, low-carbohydrate diet. And if we look back, the typical time for a high school, we're going to assume this is a high school athlete, that her time for running an 800-meter event is between 3 and 4 minutes, where a male would be slightly faster. If we consider that time, the energy system used would be primarily aerobic. It's a longer, lower intensity sprint with a longer duration, and so you want to peek back at figure 225. The aerobic system does use all pathways, but remember, everything starts with carbohydrate. So the carbohydrate requirement is going to be pretty high for this athlete. So you want to look back and say, is a high-fat diet really something that is going to be effective for this kind of athlete? What do you think?